Hi everyone, my name is Harmon Kugler with Makai Ocean Engineering, and today I'm going to be presenting a project that we've been working on for ONR titled Distributed Temperature Sensing Tow Cable. So first I'd like to give you a little bit of background information into our company, Makai Ocean Engineering, and the type of work that we do. So we are a professional ocean engineering service provider that's been in business for over 45 years, since 1973, based out of Hawaii. Over the years, we've become known worldwide for several key technical areas that we've been involved in, including subsea cable software and hardware development. Most notably, our subsea cable software suite, Makai Plan and Makai Lay, are used globally by over 80% of the subsea cable installation fleet for planning and installing subsea telecommunications and power cables. We're also a world leader in several other key areas, including marine pipeline design, ocean thermal energy conversion, and seawater air conditioning. Ocean thermal energy conversion and seawater air conditioning are technologies that use deep seawater as a renewable energy resource. So we have a significant technical history. We've been involved in multiple subsea cable and towed array SBIR and STCR projects related to the topic I'll be presenting today. That gives us a unique skill set to work on these types of unique subsea cable applications. We hold several patents for the technologies that we've developed under DoD funding. Our key resources, most importantly, are 37 employees, 29 of which hold advanced degrees in science, technology, engineering, and mathematics. We have 3 offices. Our main office, our headquarters, is at the Makai Research Pier in Waimanalo, Hawaii, where we have access to shallow and deep waters within a pre-permitted test range. This allows us to save our clients costs on in-water testing. We can rapidly deploy systems in waters, both shallow and deep, within our office space. Our second office is the Ocean Energy Research Center in Kona, Hawaii. This is where we do a lot of heat exchanger research and development, and most recently we've started manufacturing, testing, and developing our own ultra-compact heat exchangers with a wide range of applications, including seawater applications, and we're currently working on 2 separate SBIRs for the Air Force and for the Army for vehicle cooling. And our third office is located in Ventura, California, where our employees there are supporting the Ocean's Multiple Award Contract for NAVFAC XWIC. A lot of that type of work is general ocean engineering services and marine installation support. We've had a significant commercialization and transition success in our 45 years of business. In 2016, we were a Tibbetts Award winner for successful execution and transition of our SBIR projects. We've had an SBA designated commercialization achievement index of 100 out of 100 for over 10 years. And like I mentioned earlier, our submarine cable products, our software is used both by multiple government customers, and it's used globally by commercial sectors as well. On this slide, I'll be presenting the challenge that the Navy laid out in the solicitation for this project. So the requirements that they had were that they would like the performer to develop a fiber optic sensor to be integrated into ship's tow cables that measures the seawater temperature continuously along the cable's length. They'd like to replace the inaccurate temperature measurement methods that are currently used. The expected transition targets they mentioned were surface ships, including the Surveillance Towed Array Sensor System, SURTAS, Littoral Combat Ship, LCS, and cruisers and destroyers, or CRUDs. The expectations that they had for the system were that they would like the solution to be compatible with the legacy systems, including the legacy ships, the legacy tow cables, and the legacy tow cable handling systems as well. The data rate is they would like temperature to be collected every second, and the accuracy that they required was less than half a degree Celsius error along any half-meter segment of the cable. So the Navy's primary operational needs for the system to be developed under this program is the ability to accurately measure the seawater temperature throughout the water column. And they also need the system to use the existing tow cable systems that are already on board the vessels as to reduce costs and reduce complexity of transition onto these vessels. The improvement that the system should provide is the ability for the Navy to replace the existing predictive models with accurate real-time truth data. Vessels currently use predictive models with seawater injection temperature, which inherently has errors due to using predictive models instead of having real-time truth data like the system developed under this SBIR will provide. The problem that we are solving is that predictive seawater temperature modeling is not accurate. The platforms with this need, as mentioned on the previous slide, are several surface ships within the Navy. So this slide shows the solution that Makai has developed throughout this STTR program. What we've developed is called the Distributed Temperature Sensing Tow Cable, which uses an optical fiber that is embedded in the outer jacket of the tow cable, which acts as a distributed sensor. The top right image is kind of the best visual for the solution that we've developed, where in the center of that image shows a cutout of the cable that we've developed, including the fiber optic cable that's embedded in the outer jacket, which is shown as a green cable in that image. Our solution provides real-time truth data of seawater temperature versus depth, and the solution does not impact the tow cable's functionality whatsoever. The specs that we've achieved, our system includes integrated temperature sensing fibers within the tow cables, as I mentioned. And our distributed temperature sensing solution is based on top performing fiber optic sensor technologies that have been developed for other industries, including the oil and gas industry and others. Our solution has better than half a degree Celsius resolution. That's what we've achieved in lab testing so far, and we are currently in the process of testing at sea. Our accuracy is significantly more accurate than the existing, like I mentioned on the previous slide, the predictive models and seawater injection temperature measurements that are currently being used on these vessels. Our optical fiber embedding technique is part of the key IP that we've developed under this program, and that embedding technique limits any errors within the measurement and also protects the fiber optic sensor as well. So this slide shows the current status of this STTR and the development of the distributed temperature sensing tow cable. We are currently in the phase 2 base period, and we are currently at a TRL 5 where we've conducted component demonstrations of the main system components within the lab. We have plans to reach a TRL 6 within the next few months, where we will be performing system qualification and demonstration of our distributed temperature sensing tow cable on a vessel of opportunity, meaning not a Navy vessel, but just a representative vessel. And then we have plans to reach a TRL 7 by calendar year 2022, where we will be performing system integration and demonstration in an operational environment on a Navy vessel. So this slide, I really want you as a viewer to take the items mentioned on this slide, take these and kind of think about them for your potential applications. These are the key features, advantages, and benefits that our system brings when compared to the existing methods, like I mentioned, including predictive modeling and single point injection temperature measurements. So the resolution that our temperature sensing tow cable is able to achieve is less than 0.5 degrees Celsius error per half-meter section of cable. Versus predictive models, we aren't actually aware of what the resolution is of the existing methods. We were only told by the Navy to achieve the 0.5 degrees Celsius error per half-meter section. So we're able to achieve the Navy's requirements, but we are not aware of what the resolution is of the existing methods. But one thing to point out is the predictive model could actually be used in conjunction with our temperature sensing tow cable to improve the error within our system and basically account for any thermal response time between the seawater temperature, the time it takes for the seawater temperature to travel through the outer jacket of the tow cable and actually make contact with that fiber optic sensor. The data collection location for our temperature sensing tow cable is along the entire tow cable's length. So at any point along the tow cable, you can know what temperature it is with accurate truth data. Versus predictive models, they take temperature from a single point and they use predictive models to fill in the rest. And they also use periodic expendable bathythermographs or XBTs that are dropped from the vessel and take the temperature along the water column. But again, the location of those XBTs as they fall are not completely accurate. So our system provides a bit more accuracy even to that. The data collection frequency, our system is currently set at every 10 seconds. It'll collect data along the entire cable length. And same thing for the predictive model. They currently take temperature and run the model every 10 seconds. With the XBTs, as I mentioned, those are periodic. Those aren't taken every 10 seconds, but those are every so often to just validate the model is working to its operational specifications. Our system also is not affected by currents, water currents. So the measurement from the tow cable, the currents do not modify that temperature measurement at all, since it is truth data coming from the cable itself. Versus the predictive model, it can't really take into account any currents, any water currents, because those currents are often unknown. So the improved water column temperature measurements that our distributed temperature sensing tow cable, what that allows the Navy to do is improve the vessel's situational awareness, in addition to improve oceanographic mapping to support any future mission planning. So we're now focused on transitioning our distributed temperature sensing tow cable onto the Navy's fleet and making that transition beyond the phase 2. We've identified a few areas that we may need assistance. So if you are any of these parties that may be able to help in this transition, please reach out. We definitely appreciate any input you can provide. So the areas that we need help on transitioning beyond the phase 2 is we will need additional funding beyond this initial phase 2 to certify our temperature sensing tow cable for use on the Navy's vessels during their operations. We will require a temporary alteration demonstration for each of the target platforms that we're looking at. And we're currently targeting non-recurring engineering for all the platforms that I mentioned earlier, with the objective to demonstrate on one of those platforms. We will require additional funding to demonstrate on other platforms. So we're really looking for a transition advocate for some of these applications that I've mentioned, and some future applications as well. So we're looking, our primary transition advocate that we would like your input on, if you are this person, is an advocate for cruisers and destroyer tow systems. So if you work within those programs or have connections within those programs, please don't hesitate to reach out. I'd really love to hear from you and work together on transitioning this thing to the Navy. We're also looking for transition advocates for future DoD applications, which could include any future ships that have a tow cable, but some specific applications that we're considering are unmanned underwater vehicles and unmanned surface vehicles. I know that's a big push that the Navy is going for in the future, trying to deploy more of those systems. So if you have some of those applications and you are interested in this distributed temperature sensing tow cable, please reach out. Like I said, happy to talk and figure out how we can work together. So here's the transition and partnership pitch. So any of you that might think you have an application that could benefit from the distributed temperature sensing tow cable, this slide is for you. This is where I'll cover the business model, some of the next steps we're pursuing, and some of the inputs we'd like from any of you if you have any interest. So we do need input from the surface ship program offices. We need their input for the transition onto legacy systems, onto those legacy towed cables. And we're also interested in partnering with primes for future vessel applications and platforms that use tow cables. Those primes could be for the vessels themselves, or the primes that are actually developing the tow cables themselves. We can work with either of you to integrate our system into your applications. We also need additional funding to transition to other applications. With these STTR programs, we are limited to applications that we can fit within the budget. We are pursuing the primary application of interest to the Navy currently, but any other applications we would need additional funding. So please reach out if you are any of these primes or program offices that could help us on this transition. Some other transition paths that we are pursuing currently are future vessels, including, like I mentioned on the past slide, unmanned underwater vehicles and unmanned surface vehicles. So we're interested in partnering with the primes that are developing those platforms, or again, the primes that may be developing the tow cables for those unmanned vessels. In addition to the DoD applications that I've already mentioned, and the Navy applications, are oceanographic applications, including the vessels themselves. In the image that I showed a few slides back, I showed a NOAA vessel with a tow cable. That's a potential application. It's a direct correlation, but another side application that isn't directly noticeable maybe is our system could be used on oceanographic buoys that are deployed around the world. You could use our temperature sensing tow cable as a mooring line, where it would be used to collect distributed temperature at that mooring location. So that's one application. We also have other technologies that would help enable that mooring line using a cable. So please reach out if you have any applications like that. But we also like to discuss any other Navy applications with the Naval Oceanographic Office. We believe they would have some significant interest in this technology and the data that it provides. So if you are within the Naval Oceanographic Office or have connections there, please reach out. I'm happy to talk. And like I said, we're looking for transition partners for all these applications, including this oceanographic application. So primes, program offices, anyone that's interested, please reach out. So as I've been stressing in the last few slides, please reach out to discuss your needs, your project, your applications, and your platforms. Even if you aren't sure if there's a direct fit for the distributed temperature sensing tow cable, please reach out. I'm happy to discuss any of it. Again, my name is Herman Kugler. I'm Makai's Business Development Manager. You can see my contact information on the bottom left there. Reach out during the event, or if you aren't able to make time during the event, shoot me an email or give me a call anytime after the fact. Thank you.